So we've already learned how to complete the square. And I said for complete the square, it's always better with an even middle term. We don't get any fractions. If you have an odd term, the quadratic formula is actually an easier method. You can use both for both options, but if there's an odd middle term, the b is odd, we can use this quadratic formula. Now, we've got three numbers that were given in general form, a, b, and c. We just have to take those three numbers and plug it into the quadratic formula. So, the key thing is, and I want to start with this, if it's in general form and there's odd middle term, definitely use the quadratic formula. If it's general form and it's a word problem, we're going to end up with a decimal anyways, we might as well use the quadratic formula. So the first thing we want to do is take our equation and recognize the three numbers that are in it. And careful with the negative. The c is -4. So we're going to write out the quadratic formula and put those three numbers in. So what you'll see is b goes in two different spots. So I've put -5 in both, and I'm careful to put -5 in brackets. When we put this into the calculator, we have to square the negative. A goes in two spots, right inside the square root and at the bottom. And c, there's only one c in the whole formula. So we plug these in. Start with this, especially if you have a one-line calculator, just type this in. So after typing it into the calculator, we get root 73. What you'll find is if there's an odd middle term, most of the time, you won't have to do any simplification. No perfect squares goes into 73. We can't simplify it anyway. 5 and 6, we can't simplify. So in that case, we're done. Those are our two answers. -5 plus or minus root 73 all over 6. Okay, let's try this one. And again, just like complete the square, we are looking at when y is 0. The quadratic formula is assuming that we're finding the solutions when y is 0. Now this one's a little different. We took all the three numbers, a, b, c, plugged it into the formula, and we got this. Always start with this right here. We end up with 96. Now, if you think about it, there's a perfect square in that. In the last one, we didn't have to. We didn't have to simplify. And if we go back, we realize, hey, the middle term's even. This is what it means. Like, we can still do it, but there'll be extra work at the end. And so what we get is root 96 simplifies to 4 root 6. And we can do even more. We've got 10 on bottom, both numbers on top, both terms are divisible by 2. So we can't just divide the 6 and the 10, we have to divide all three by 2. And there we go. Now we have the answer. We have two answers because it's plus minus. That's as far as we can go. We've simplified as much as we can. So the key thing is if you have an even middle term, you know you're going to have to do extra work at the end. So you may actually want to use complete the square, but you can still use this method. The next one is different from the other ones. We don't have a y, so we don't have to make it 0, but we have things on different sides. The key thing is I want to keep this positive, so I'm going to move these ones over. And this one plus 4, plus 4. Now this one has a perfect square. It simplifies nicely. And because we get rid of the radical, we can actually figure out both answers. So I'm going to do the plus first. And I get my first solution, -1. If I do the other one, I get my other answer. So I get my two answers. because it's a perfect square. So the last thing I want to go over is, what are the solutions? What do they mean? So in this case, we got x equals negative 1. So if we draw a graph, x equals negative 1 is right there. X equals negative 4/3 is right there. So basically, we've taken a quadratic and we've gotten rid of everything except the x-intercepts. The solutions is where the quadratic crosses the x-axis. So here's what the parabola looks like if we graph the whole thing. As you can see, I've highlighted the 2 dots. Those are the x-intercepts. Those are the 2 solutions that we got from complete the square. So pause the video. Try this one on your own. See if you get the same answer, and then check your answer afterwards. So hopefully you got to this point and said, wait a second, I can't do square root of a negative. No solution. It's not possible. And basically what's happening is we have a quadratic that does not cross the x-axis. The whole point of the quadratic formula is to find where it crosses. If it doesn't cross, there is no solution. If there's a negative in the square root, in the radical, there is no solution.